डियर स्टूडेंट्स, अस्सलाम वालेकुम। हमने आज सीखना है व्हाट काइंड ऑफ रूट्स a quadratic equation can have and what is the nature of roots of a quadratic equation। अगर आपको एक quadratic equation दी गई होगी, लेट्स सपोज यू आर provided with a quadratic equation ax square plus bx plus c equal to 0 where a is non-zero real number, then it has real roots, or we can say that real roots exist for this equation if b square, this coefficient of x square minus 4 times a into c, where a is the coefficient of x square and c is the constant term, is greater or equal to 0. If the difference of these two terms comes out to be equal to is greater or equal to 0, we can say that the equation has real roots. So a quadratic equation of the star ax square plus bx plus c equal to 0 has real roots only if b square minus 4ac equal to, is greater or equal to 0, where a b c are the a is the coefficient of x square, b is the coefficient of x, and c is the constant term. So, or we can write down b square minus 4ac equal to d. So d is b square minus 4ac is known as the discriminant of the equation. So if d is greater or equal to 0, or simply we can say that if d is greater or equal to 0, then the equation will have real roots, where d is known as the discriminant and is equal to b square minus 4ac, where these abc are the coefficient of x square, x and c is the constant term. Now it has the inequality has two signs together, that is greater than sign and the equality sign. So this इससे हमें यह पता चलेगा if d is greater than 0, then the roots are real and distinct. So different roots, two roots will exist but real roots, but they will be distinct. If d is greater than if d is equal to 0, sometimes you will get d equal to 0, that is discriminant is equal to 0, then the roots are real but equal. So in this case real and equal roots will exist. So real roots may be of two types, either distinct or equal. If d is positive, then distinct roots may exist. If d is equal to 0, then equal and real roots exist for a quadratic equation. Now in case d is negative, that is less than 0, if d is less than 0, that is b square minus 4ac is less than 0, then real roots do not exist, but the roots may exist, they may be complex. So only in the about two cases we can say that real roots exist, that is either d is equal to 0 or d is greater than 0. So it is all about the nature of roots of a quadratic equation. Now we will come to solve the exercise number 4.3. Let us try to solve the exercise number. Now we will come to solve the exercise number 4.3, where we have question number 1. Question number 1 says that find the roots of the quadratic equation if they exist by the method of completing the square. So we have to first check whether the real roots exist or not. If real roots exist, then we have to find the roots by the method of the completing square we have learned earlier. So now we will have a look on the equation. Our given equation is 2x square minus 7x plus 3 equal to 0. So here instead of a you have that is coefficient of x square is 2, and b instead of b we have minus 7, and c is equal to 3. Now we know that discriminant is equal to b square minus 4ac. Now instead of b you have minus 7, so minus 7 square minus 4 into 2is 2ac. Instead of a you have 2 and instead of c you have 3. So we will get minus 7 square means positive 49, minus 4 2s are 8, 3 are 24. So we will get 25. So d is equal to 25, but 25 is a positive number, so we will get d as a positive. When d is positive, we have learned that when d is positive, then real and distinct roots will exist. So the equation has, our given equation has real and distinct roots, and these roots can be calculated by the method of completing square as follows. Now we will solve the equation by the method of completing square. Let's solve it. Now our given equation is twice x square minus 7x plus 3 equal to 0. We will divide the equation throughout by 2 so as to get the leading coefficient as 1. Therefore we have now x square minus 7 by 2x, we have to divide throughout by 2, so we will get 7 by 2x plus 3 by 2 equal to 0. Now this we have to complete the a plus b whole square identity by this way: x square minus 2 into a into b. Here we multiplied by 2 and divided by 2, so that the term is no longer altered. We multiply by 2 and divide by 2, so we will get 7 by 2 2s are 4 over here, so that 2 2s are 4, we are left with the same 7 by 2 again. Now we have 7 by 4 whole square. In order to complete the square, you had to know that it is twice a into b. Instead of b you have 7 by 4, and we will write 7 by 4 whole square, so we will get a square minus 2ab plus b square. So instead of b you have 7 by 4, and we will write 7 by 4 whole square. We have introduced the term 7 by 4 whole square. Now we will subtract it from the equation, so we will get 7 by 4 whole square, so that the equation will remain unaltered. By subtracting the same term, we have added it, so plus 3 by 2 is the constant term in the equation, is equal to 0. Now a square minus 2ab plus b square, up to this we can write it by using the identity a plus b whole square as a minus b whole square. A square minus 2ab plus b square, you have x minus 7. Instead of a you have x, instead of b we have 7 by 4, so we will get a minus b whole square out of these three terms, minus 7 by 4 whole square exists, and plus 3 by 2 is there, is equal to 0. Now x minus 7 by 4 whole square is as such. Now we will distribute the square into the numerator and denominator separately, so we will apply square to the numerator. We will get 7 square means 49 and 4 square means 16, plus 3 by 2 equal to 0. Now x minus 7 by 4 whole square is as such. We will transpose all the term to the rest of the term to the right hand side. We will get 49 by 16 as positive and 3 by 2 as negative by transposing them to the right side. Now x minus 7 by 4 is as such. We had to cross multiply in order to simplify the right hand side. We had to cross multiply the term, that is 2 into 49 means 98, and 3 into 16 means 48. Divided by 6 2s are 32. So we got, now we are over here, x minus 7 by 4 whole square is equal to 50 divided by 32. 98 minus 48 means 50 divided by 32. We got the 52. 50 divided by 32 over here. Now it can be further simplified as such. Now we will get x minus 7 by 4 whole square is equal to 25 divided by 16. Dividing the numerator and denominator by 2, we will get 25 by 16. Now in order to find the value of x, you have to take the square roots on both sides. We will get, now taking the square root on both sides, we will get this square will vanish from the left hand side, and square root will appear on the right hand side as such. We have plus minus square root of 25 divided by 16. Now x minus 7 by 4 is equal to plus minus square root of 25 is 5 and square root of 16 is 4, so we will write 5 by 4. Now we will In order to get the value of x, you have to transpose this n by 4 minus n by 4 from left hand side to the right hand side. We will get 7 by 4 as positive plus minus 5 by 4. Now in this way we can get two values for x, that is one with the plus sign and other is with the minus sign. Now x is equal to 7 by 4 plus 5 by 4, and x is also equal to 7 by 4 minus 5 by 4 with the negative sign. So we have now two values for x. One is x is equal to 7 by 7 plus, we have to sum these two terms. We have denominator same in both the terms, both the numbers, rational numbers. So we will add their numerators and divide by 4. So 7 by 4, 7 plus 5 divided by 4, and other is x is equal to 7 minus 5 by 4. Over here we have x is equal to 12 by 4, and other is x is equal to 2 by 4. Now x is equal to 4 3s are 4 3s are 4 3s are 12. One value is x is equal to 3, and other value is x equal to 1 half 1 by 2, that is. So we have two roots for the equation. One is 3 and other is 1 by 2. So these are the roots of the given equation. In this way we have solved our equation by the method of the completing square and found out its roots, that is x, one root is 3 and other is 1 by 2.